video, I'm just going to cover the basic introduction to addition polymerization, and then I'm just gonna go ahead and talk about some common addition polymers that are used in everyday life. For example, polyethene, polypropylene. We've got polychloroethylene, PVC, obviously used in electricals for insulation and so forth. And then I'm probably just going to end with helping you sort of deduce structures, monomers and repeating units of different polymers. So first off, there's a general equation that you're going to have to sort of remember. It's quite useful to, well, in my opinion, if you learn this general formula, then you will find addition polymerization quite easy. It can look quite challenging at the start, but yeah, it's definitely not a topic you should worry about too much. So what I've drawn here, we've got our monomer here. The W, X, Y, and Z is it's not necessary to identify what's here. This is just the general formula, and we're just showing this is just the what we call as the monomer here, and here is the polymer. It is the I'm doing purple, why not? Polymer, and let me just draw everything in here. So I'm not explaining too much here. I'm just suggesting that this is, sorry, my mistake. This is technically defined as the repeating unit, as given by n. N is just a number representative of the amount of chains that polymer, but it's typically not defined, especially well, at least at A level it's not. So we'll draw in our Y here, and you can see how this double bond's gone to this single here, and we've got 2 bonds coming on the outsides of our brackets. These brackets are typically either curved like this or square brackets, and we have our N repeating unit here. So what do I mean by a polymer? Well, a polymer you might be thinking of biology here maybe, and you wouldn't be wrong. You can have polymers in G, but really what we're thinking of is sort of organic polymers, right? So let's for example say we have this very long chain, and polymers can be millions of chains of atoms long, and say we have maybe hydrogen, and maybe maybe fluorine. I don't know why I changed my mind then. And then we have like this, and so forth. And really, what this model up here that I showed you, this repeating unit, does is it just simplifies it all down. It just simplifies it all down into just the 2 repeating units here. And we'll just have these. So now that I've shown you this is just a little challenge here. Now that I've shown you the monomer to the repeating unit, and it's from this polymer here, how might we be able to draw the monomer for this polymer, for this repeating unit? Well, we know it's going to have 2 carbons, and they're obviously going to be double bonded. It's going to be alkene, and we can just fill in the atoms, the hydrogens, fluorines, and here. And so, I mean, you could argue that this would be here, but I don't think it matters too much. We're going to do it anyway, just to be 100% correct here. So this is all cool, but what are polymers really used for? Well, I'm gonna talk you through some common polymers. I have about 5 to show you, I think, and I'll go through their sort of uses in everyday life. So first one I want to talk about, first one to consider is the most simplest. Ethene. And you're probably quite comfortable doing this one yourselves. It's obviously going to be written as so. Now, how you would name this as a polymer is obviously a repeating unit. This is the monomer, and its name is ethene. And but what about the polymer of ethene? Does it have a different name? Well, sort of. It's not very original. It's just noted as polyethene right here. And just polyethene, you might already know, is typically used in plastic bags and bottles. And I'll cover this in a later video. Why? But typically, as you already know, plastic is quite hard to break down, and that's because of these polymers that are formed. They're very hard for natural elements, so forth, to break them down, and that's why we're really trying to reduce plastics everywhere at the moment. But but I'll definitely go into that in probably the next video. So the next polymer, the next monomer I'm going to look at here is propene. Propene, and obviously you guys have guessed the polymer name already. It's going to be polypropylene. But people can sometimes get a little bit confused about the CH3, so we're definitely going to just look over it very, reasonably quickly. So I'm just going to draw its repeating unit here. This is the monomer, and here I'm just going to draw. So within the repeating unit, you typically just want to have the 2 carbons around the double bond here. It's never seen as, and you'll be marked down if you try and include 3 carbons. This is just not a thing. You have to just include the 2 carbons here, and an N for, obviously, as I've told you before, number of repeating units. So obviously we can fill in our hydrogens here, and this CH3, it can be a bit confusing to start off with, but we know the chain length is 3 carbons long, so we can quite literally just put in CH3 here, and so we have our completed repeating unit of polypropylene. We'll write that down for you guys. It's quite literally the same as one before. This is how it's named, polypropylene. And polypropylene is it's quite strong. It's used in ropes and making crates, etc. So the next addition polymer I'm going to look at is chloroethene. And what chloroethene is used for is, as I've already said, it's really used for electrical cable insulation. So, I'm gonna challenge you guys. I'm gonna draw the monomer here. And I want you guys to pause the video here and see if you can draw the repeating unit of polychloroethene, PVC for short. Right, so PVC, you could write it as polychloroethene, but I'm just going to refer to it as PVC from now on. You may have heard it before. It's quite commonly known. So how we would draw this is, remember the brackets. I like to draw it in order of remembering things first before actually drawing the polymer. And again here we can just draw in our 2 carbons that's surrounding the double bond here. We can draw in our hydrogens. It's hydrogen, and then we can just draw in our chlorine, like so. And that is polychloroethene, PVC. So next up, we are going to look at a more complex addition polymer here, which is more commonly known as polystyrene, but its polymer name is polyphenylethene, and as you can guess from that, it's got a phenyl group. And what a phenyl group is, I haven't covered this before on my channel. It's literally think of a benzene ring attached to another carbon chain. Okay, so I'm going to draw the monomer of phenylethene here. So phenylethene. Sorry about that. I'm just going to draw. I'm not going to shorten down anything for you guys. There we go. Just our other 2, like so. So this is phenylethene, and this is obviously our monomer. So, you guys probably already know how to do this, but I'm just going to show you. It gets so simple drawing these addition polymers that those 2 markers, it might be 1 marker, asking you to draw the repeating unit of this polymer, it will get so easy that it's honestly just 3 marks. It's 3 marks. So we're going to draw in our hydrogens here, and literally all we do is draw in our aromatic hydrocarbon here. Our aromatic group, our phenyl group, right there, and its common name polystyrene. I hope I'm not butchering that name. Alright, and I'm in the OCR spec, I'm not sure if you get marks for that, so I'd probably just write down it's polyphenol ethene. Polyphenol ethene. And what everyone knows, polystyrene. It's used for packaging. You know, these little peanut things. Right. So that's probably the most complicated one we're going to have to look at, and that's covered in the A-level spec. So the final one I'm just going to look at is tetrafluoroethylene. So, and for short, Teflon. So these are actually common polymers that you would have heard of in everyday life. So we have tetrafluoroethylene, and this is typically used for sort of non-stick coatings on your frying pans, on cooking utensils, so forth. And this is just a fluorocarbon. This is just a fluorocarbon. So what I mean by that is it contains only carbon and fluorine. Very original names here today. So we have the monomer here. We have the monomer, and I want its repeating unit. I want you to pause the video right now and draw me the repeating unit of Teflon, of polytetrafluoroethylene. So go ahead and give that one a go. So obviously we're going to start off with our two carbons, our two main carbons, and that surrounding double bond. And we've got our repeating units, N, our N number of repeating units, and we simply have 4 fluorines. Fluorine? 4 atoms of fluorine. I can't say that now. Okay. Anyway, I hope you've enjoyed this video, and maybe it makes a little bit more sense to you. Oh, one more thing. I'm gonna give you a question. I have polypropylene. I want the monomer, and I want the repeating unit, and I would like the, do it down here, yes, I would like I'd like the at least 2 chains of the polymer. I won't go into too much detail about that, but just pause the video here and try and give those a go. So chloropropylene, where I'm going to draw as CH3 and remember this is 1 carbon, or this is 1 carbon, so this is carbon 2 here. So we're also going to have the chlorine on carbon 2. Chlorine, and then our 2 hydrogens in here. And this is the monomer of 2-chloropropylene. So what about the repeating unit? Well, brackets, the brackets and the N, and then we can start thinking about drawing the polymer, the repeating unit. So I'm going to draw my CH3, my hydrogens, and then my chlorine, and boom. There we have poly-2-chloropropylene. What about the polymer? Well, I didn't really give you guys much detail. I just said I wanted at least two chains, and by what I mean by two chains is quite literally two of these. So I still want an empty a bond leaving a chain leading off, but that's fine. CH3 Cl, but we just don't have to include the brackets here, really. Sometimes I've seen a question like this before, and I thought I might ask it, so there you go. And that's two chains of the polymer. So, well, two repeating units per se. So I think this video covers at least year 1 of the spec. I'm pretty sure there's not much to year 2 about polymer, typically about addition polymerization. So hopefully you can take a lot from this video. Thanks for watching.